This is problem 4 on practice exam 1 in module 5 of the book Problem Solving Guide for Electromagnetism and Optics. Problem 4, a wire of some unknown alloy is 1 meter long, has a diameter of 2 millimeters and a mass of 20 grams. Each atom in the alloy contributes 1 electron to the current. When a 250 milliamp current is passed through the wire, the drift speed of the electrons is 1 times 10 to the minus 5th meters per second. What is the average atomic weight of the alloy? Atomic weight, grams per mole. How are we going to get that? I don't know, but at least I can draw a good diagram. There's the wire. Let's label what we know. We have 250 milliamps going through it. Diameter is 2 millimeters. Length is 1 millimeter. We also know that the drift speed is 1 times 10 to the minus 5th meters per second. And we know that the mass is 20 grams. So let's think through this. 250 milliamp current, we can get the electron flow rate. 250 milliamps is 0.25 amps. 0.25 amps is 0.25 coulombs per second. There's 1 electron has 1.6 times 10 to the minus 19th coulombs, so we get 1.56 times 10 to the 18th electrons flowing every second. Since the speed of the electrons, it's given 1 times 10 to the minus 5th meters per second, and there are 1.56 times 10 to the 18th electrons passing every second, there must be 1.56 times 10 to the 18th electrons in a 1 times 10 to the minus 5th meter length of the wire. The number density of the electrons is number per volume. Here is the length of the wire. I converted it to centimeters. So instead of 1 times 10 to the minus 5th meters, I have 1 times 10 to the minus 3rd centimeters. And the diameter is 1 millimeter, which is, no, the diameter is 2 millimeters, the radius is 1 millimeter, and 1 millimeter is 0.1 centimeters. So I have the number divided by the volume, 4.97 times 10 to the 22nd free electrons every cubic centimeter. And this is the number density of the atoms, 4.97 times 10 to the 22nd atoms per cubic centimeter. The volume of the wire, it's a cylinder, thin cylinder, pi r squared L. So I can calculate that volume, 3.14 cubic centimeters. The mass of the entire wire is 20 grams. The density of the alloy, we now have the mass and we have the volume, 6.27 grams per cc. The density of the metal in which that wire is made. So now we have almost everything. 6.27 grams contains 4.97 times 10 to the 22nd atoms. Because the density is 6.27 grams per cc, and the number density of atoms is 4.97 times 10 to the 22nd atoms per cc. The atomic weight is the number of grams divided by the number of atoms, and then you convert that to moles. If you do the math, you get 77 grams per mole. And that is the atomic weight of the alloy. That's a good problem.